everyone. My name is Swastika Malavadkar and I am from KV Institute of Technology, Hubli. And today I will be giving my project presentation on lane line detection using computer vision. So, what is a lane line? I would like to give you an overview on this. When we drive, we use our eyes to decide where to go. The lines on the road that show us where the lanes are act as constant reference for where the steer of the wheel is. Actually, one of the first things we would like to do is developing self-driving cars, is to automatically detect lane lines using an algorithm. So I have made this project for mainly giving light on self-driving cars. So in this project, we will detect lane lines in images using Python and OpenCV. OpenCV means open source computer vision, which is a package that may be useful for tools for analyzing images. So for this I have used color selection. Let's dive into it. So this one, here I have extracted the CSV file from Kaggle, and from here the actual code starts. This code from here, it represents the color selection. We know that some colors, for example lane lines, are usually white in color, and we know that RGB value of white is 255, and here we will define a color threshold in variables, that is red threshold, green threshold and blue threshold. So this vector contains the minimum value of red, green and blue RGB that I will allow in my selection. So this will be the code for that. So input image. For example, I am giving image of road. Let us consider this road. So this is how it will detect it, the output. So this is the color selection part. So next, this code. Starting from here, we will now see the region masking. I'll assume that the front facing camera, that look, the image is mounted in a fixed position on a car, such that the lane lines will always appear in same general region of the image. Next, I'll take the advantage of this by adding criteria to only consider pixels of color selection in the region where we accept the where we expect to find the line lanes. So check the code below. We'll check the code now. Here the left bottom, right bottom and apex represent the vertices of the rectangular region that I would like to retain for my color selection, white masking, everything else out here. Here there is left bottom, right bottom and the apex. So here I am using a triangular mask to illustrate the simple case. So, but we can use a quadrilateral and in principle we can also use any polygons. So the image formation would be like this. Here we have taken a triangular one. So now the part which is highlighted here is our region of interest, which, like for example, these are the straight lines and this is another straight line. So here I am considering this line because this is a region of interest for now, because a car will be going on one lane only. So the color selection in the triangular region would be represented like this, and region mask image would be in green. So now we have let us say that we have successfully detected the lane lines, but have we really detected them? Let's find out in the below code. So to verify the if we have done the upper all the codes correct, we have done this code for the verification purpose. Now we got a yellow line here. Here we got a yellow line. So let's know what's the yellow line here. So the gray selected image, and our output will be another image called edges. Here in this code I have used low threshold, high threshold and edges for the yellow line detection. This algorithm will first detect the strong edge, that is strong gradient pixels above the high threshold, and reject pixels below the low threshold. Next, the pixel with value between low threshold and high threshold will include as long as they are connected to strong edges. The output of the edge is binary image with white pixel and tracing. This is the image. This is the candy edge detection image I get after the output. Okay. So now, what would make sense as a reasonable range for these parameters? In our case, converting the grayscale has left us on 8-bit image. So each pixel can take 2⁸, that is 256 possible values. This range implies that the derivatives will be on the scale of tens or hundreds. So let's move on to the next part of the system. Here you can choose kernel size and for Gaussian smoothing to be any odd number. A larger kernel size implies averaging or smoothing over a larger area. So here for the smoothing of the detecting line, we are going to use Gaussian blur, and this is the code. Yeah. Now for the smoothing, the effect we are getting here is by Gaussian blur effect, and this is also this is colored in red. The colored line in red and the region of interest are in blue. Next, this code is for Hoff transform and detecting lane lines. What is Hoff transform? In the image space, a line is plotted as x versus y. But in 1962, Paul Hoff devised a method for representing line in parameter space, which we call it as Hoff space in his honor. So this is the code. Yeah, this will be the code, and finally what we get here is the green line is the that side. The green line which is there is the path where the car will go. The self-driving cars would detect the green images and would go on the same lane, and the red lines that are there, it won't exceed that path. So we can say that we have successfully detected the lane lines from different images using OpenCV and no deep learning here. I have made a video for this. So this is how the self-driving cars would detect and go on the same lane. Now I would like to show you my Streamlit project, my app. I have extracted the solid white right images and the solid yellow images and videos from Kaggle, as I have shown in upper codes. So this is my URL. I will copy paste the code here. So this is lane detection app which will be very useful for future users.